The alligator was 32 inches long here, and it grew by 6 inches. So its initial length was 32, and it ended up being 38. It told us that in the problem, right? So 32 plus 6, it grew 6 inches. We needed to just find the difference between 38 and 32. And then our percent change is just 6 divided by 32. Well, if we do that, we're going to get a decimal, right? If you punch 6 over 32 into a calculator, you're going to get a decimal. But that's okay because we know how to make decimals into percents and percents into decimals. We talked about that last week. So what I'm going to do is I am going to present in a different way here so you guys can see what I am doing. And if I punch in 6 over 32, 6 divided by 32, enter. It is 0.1875. Well, I know that to make a decimal into a percent, all I need to do is move this decimal point over 2 spaces, which is the same as multiplying by 100. If I multiply by 100, that moves the decimal over 2 spaces. So again, I want to make a decimal into a percent. I need to move the decimal 2 spaces. There's your percent, right? And you can see up here, I think you can see up here, it's small, but this was our 0.1875 was the decimal we got when we entered 6 over 32. All you do to make that a percent is multiply by 100. Or you can do it, the trick is to just move that decimal place 2 spots to the right. And it would be between the 8 and the 7, which it is right here, right? So 18.75% is the percent change. I'm going to have to switch the screen again to present the tab so you can hear the rest of the audio. All right.
It's the ratio of the change in length to the original length. Use division to write the ratio as a decimal. To express the decimal as a percent, multiply it by 100. The alligator's length increased by 18 75/100% this year. That's a lot to grow in 1 year. Maybe we should stand a little further away. Now you know how to solve a percent increase problem using the percent equation. You can solve similar problems involving percent decrease using the same equation.
So let's start the activity. This is exactly what we just did, so I don't know what this is asking us to do. This is the same problem. The change in length equals percent change times original length, right? That's how we got, it's just showing how we got what we got, right? The new length is 38. The old length is 32. So 38 minus 32 was 6, right? It grew 6 inches in a year. The alligator grew 6 inches. The total length last year was 32. So 6 over 32 was the percent change. And that's what we did. That's exactly what we just did. All right. Let's go on and let's do. Aha. So now it's saying it's going to continue to grow at the same rate next year. It's 38 now. It was 32 inches last year. It grew 6 inches. It's 38 inches this year. And it's going to grow at 18.75%. Like maybe scientists have studied alligators and they have concluded that alligators grow at 18.75% per year. So we need to fill in the blanks here. I'll use blue. And I want to get this to the right spot so that I can write everything I need. Okay, good. So here we go. What will be the length of the alligator next year if its length changes by the same percent as it changed this year? So again, if the scientists studied alligators and say, okay, they always grow at 18.75%, then we know that we can use this equation. They have percent change times length this year equals change in length. So the length this year is 38, right? 38 inches. So we would just multiply this 0.1875, which is the same as 18.75%, right? In a decimal, this is 0.1875, because all we did was take the decimal from 18.75 and move it 2 spots to the left, right? That's how we make percents into decimals and decimals into percents. We can just move the decimal 2 spots over. If you're going percent to decimal, it goes left. If you're going decimal to percent, it goes right. Okay? 0.1875 times 38 equals what? That's going to give us this, the amount it grew. The amount it grew. So I'm going to use a calculator to do this. You won't be able to see it on the screen, but 0.1875 times 38 gives us 7.125. Oh, hold on. That was the growth, okay? It grew 7.125 this year. So now we just got to add these together. It was 38, and now it grew by 7.125. So we just add those two numbers together, 38 plus 7.125. So I'm going to add 38 to that, and we get 45.125. So its new length next year, if it grows at the same percent, will be a little more than 45 inches. 45.125 inches to be exact. And those little, if you see this, people use these little marks. 1 mark means feet and 2 marks means inches, right? People abbreviate feet and inches sometimes using those little marks. Or you could say inches by writing IN, or feet by writing FT. But that's what that means. A lot of people in construction use these little marks, like they look like quotation marks almost. 45.125 inches. Okay. So there we go. Are we getting better at percents? How we feel about percents? Are we at least good? Are we at least getting good with how to make a percent into a decimal and how to make a decimal into a percent? If I say what's 64% as a decimal, you should know that that is 0.64, right? If I say I need to know, well, let me just go to the Jamboard here. And let me present a tab. If I say what is 62% of 90, you need to know that this means, let's do this. Let's even do this. Erase. If the question asks you, what is 62% of 90? You need to know that 62% needs to be a decimal, 0.62, and you need to know that the word of means times. So then that's all you do. If you know that 62% as a decimal is 0.62, all you got to do to make a percent a decimal is put the decimal point right in front of the number, right? Now that only works for percents between 0 and 99. For percents like 100, if I have 124%, it's going to be 1.24, right? But all you got to do is put a decimal in front of the percent. If it's between 0 and 99, you're just moving this point right there, 0.62, right? That's it. Obviously, for 124%, you're moving the decimal 1, 2, which makes it 1.24, right? There's the point that we moved. All right. That is the number one priority skill that we need. We need to be able to know, and Gabby was doing an awesome job about it on office hours yesterday. We worked on some Delta math problems, and Gabby was acing it. She was getting these. It was asking you, like, what is, so the homework assignment, and when you do it, Deasia, the homework assignment will ask you, like, what is 100% of 43? And then it'll ask you what's 0% of 43. And then it might ask you what's 25% of 43. Okay, there are like 5 or 6 different boxes. You know that 100% of anything is the whole number, right? 100% of something is all of it. So 100% of 43 equals 43. We know that 0% of something is none of it. So 0% of anything is 0. So those are the two easy ones. And then it goes on to ask you what's 25%, what's 75%, and what's 50%. If you get what's 25% of 43, all you need to do is go 0.25 times, of means times, 43. And then you just use a calculator. 0.25 times 43 equals 10.75. Okay. Let me do a couple more of these on here. I'm going to clear the frame. I'm going to clear the frame and make up a couple. Let's do, I don't know, let's do 25% of 60. And let's do 40% of 110. Why not? Okay, so we have a couple things that we need to do here. We know that 25% needs to be made into 0.25, right? We know that the word of means multiply, times. And we keep the 60, and that's all we do, right? Same thing here. We know that 40% means 0.40. 0.40. Oh, messing that up. $0.40. We know that the word of means times, and we leave our 110, and we have a problem we can solve here, right? 25% of 60 means 0.25 times 60. Of means times, just like per means divide. So all you got to do is now solve this. You can maybe do it in your head. If you can't do it in your head, you can use a calculator to do it, right? So I'm going to present this as my entire screen so you guys can see my calculator. If I'm doing 25% of 60, I'm doing this. 0.25 of 60. 0.25 of means times 60 equals 15, right? That would be your answer. What's 40% of 110? Oh, 0.40 times 110 equals 44. That's all you got to do. When you see this, you need to know what percent translates into a decimal, and you need to know that the word of means times. And then if you can remember those two things, you will ace percents. Okay? You will ace percents. And again, like I said, you guys will start getting better at these when you see, like if you see a decimal and it says, oh, what percent is 0.71? You'll be able to look at that and just know that that means 71%. If you see 0.3 and it says, what percent is that? You'll just look at that and know, all right, I'm going to add a 0 to the end. And that means 30% because percents are always in at least 2 digits, right? Well, technically not, but if we have one decimal place, we're moving the decimal 2 spots over. So if we don't have a second decimal, we have to add a 0, right? 0.3 is 30%. If you see 0.08 and want to make that a percent, 2 spaces, that would be 8%. You guys will get better at doing these so that you can just look at these and know them and do them in your head, right? And it's really easy if it's a 2-digit decimal. It can even be a 3-digit decimal. It could be 0.612. Well, you know that that's going to be 61.2%. Okay? Because you're moving the decimal 2 spaces to be right there. 61.2%. You will get better at those. All right. So is everybody getting the hang of percents? Everybody good on that? How do we feel about percents? Do we feel good? Do we feel bad? Do we feel indifferent? Do we feel, I don't know, how do we feel about percents? Do you guys get it? Are you guys having some success? Is the light bulb coming on? Right? We just need to remember, like I said, to make a percent into a decimal, 25% becomes 0.25 because the decimal point moves over 2 spots, right? That's how I got 0.25 here, and of means times. If you can remember those 2 things, you are golden on percents, okay? Let's go to Savas. And let's find a percent decrease. Last year, a website had 40,000 visitors. This year, it had 37,000. So it decreased, right? The traffic on the website decreased this year, all right? And who knows why? Maybe it's a news site and they just didn't write as many good articles. So not as many people went to their news site, right? If it's, I don't know, whatever. If it's local12.com or Cincinnati Enquirer or something, right? Last year they had 40,000 hits and this year they had 37,000 hits, right? Their traffic was down. We are going to find the percent change in the number of visitors from last year to this year. So let's look at how we're going to do this. Click on each part of the diagram for more info. The percent change is a percent decrease because the number of visitors decreased. Obviously, that's what we're looking at, right? Well, that's concerning because there's supposed to be something else to click on and it's not coming up. It just came up as like the broken link thing. So right here, it says the change in attendance is 3,000, right? Not really attendance. It's traffic. Not people aren't physically there. But 3,000 less people came to the website this year. So how are we going to find the change? Well, it was 40,000 and we lost 3,000. So obviously that means 37,000 this year. let's go to the next slide and look at how we are going to find the percent change. All we need to do is divide 3,000 by the old total, right? We use the percent equation. The change in the number of visitors equals the percent change times visitors last year. We know that the change in visitors was 3,000, and we know that last year there were 40,000. So you end up dividing both sides by 40,000 to cancel this out, and you get 3,000 divided by 40,000. That's it. That'll give you the percent decrease, which is 0.075. That's not a percent. That's a decimal. So to make it a percent, and I think you guys can see my mouse cursor, to make it a percent, we need to move the decimal over 1, 2 spaces. So you can see how that works. It goes from here over 1, 2, and it goes between the 7 and the 5. That's how they got 7.5%, right? If I go here and clear this, and I go 0.075, and I want to make it into a percent, well, what do I got to do? Move the decimal place over 2 spots, so then we get 7.5. 7.5%. So this decimal, 0.075, equals 7.5%. These are the same thing. 2 different ways of writing the exact same thing. 7.5% is the same as the decimal 0.075. All right. So that was an easy one. Percent error. This will be interesting. All right. Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296, right? And whenever people go to sports events, they scan the tickets, right? The tickets have a barcode on them, and that's how they scan your ticket to make sure it's a legitimate ticket and they let you in. They don't really do that at high school games, but if you go to a college game or a pro game, you go to a Bengals game or a Reds game or a Cincinnati Bearcats basketball or football game, you have a ticket and it has a barcode on it and they scan it. Well, that computer tabulates how many people have gone through the gate, right? Because those scanners, they connect to the internet and they verify the barcode as being legit, but they also count the number of people through the turnstiles. So the people that scanned into the game with their tickets were 3,296. Sean was just looking around, and I do this too when I go to games. When I go to Bearcat games, I'll look around the stadium, and I know the stadium holds 40,000 fans, right? The record attendance is 40,126, right? That's max capacity, 40,126 at Nippert Stadium. I'll look around the stadium, and my buddy that I sit next to that has tickets next to me, and we'll say, it looks like there's about 35,000 people here. We're estimating, right? There are a few empty seats here or there, but we think there's about 35,000 people here. Now, there might be more because maybe some of those people are getting up to go to the bathroom or to go get a concession stand and go get a hot dog or whatever, right? But we'll estimate. Or if it's a cold night and rainy and it's a night game in November, some people stayed home. They didn't come because they didn't want to sit outside in the cold rain when it was 37 degrees. So we'll look around the stadium and be like, well, it looks half empty to me, and it holds 40,000. So there might be 20,000 people here. We're estimating. We don't actually know. So Sean estimates that there's 3,000 people here. The actual attendance was 3,296. What is the percent error of Sean's estimate? Round to the nearest whole percent. So what it's asking us is we have to subtract, and you can see the absolute value here. It's asking us to find the difference between his estimate and the actual attendance. So we can use the absolute value equation I don't know really why it matters to use the absolute value. You could just subtract 3,296 minus 3,000 and get the exact same number here. The difference between his estimate and the actual attendance was 296 people, right? This minus this equals 296. So he was off by 296 in his guess. So all you need to do is, what's 296 divided by 3,296? The difference divided by the actual attendance. They did that. They punched this into a calculator, right? 296 divided by 3,296 equals 0. It gives you this really long number, right? But we can find out. It rounded off here. It rounded off to 0.0898, right? Because the next number is a 0, so that's 4 or less. And we just rounded it off to this. That's how they got 0.0898. Now, remember how we make a percent into a decimal. We would 0.0898 to a percent. Well, I need to move the decimal 2 spaces over. It's going to go here. So this would be 8.98%. But it said round to the nearest whole percent. Well, 8.98 is really close to 9, right? You look at this, if we're rounding to this number, we look at the 9. 9 is 5 or more. So we're just going to chop this off and round this up to 9%, right? So again, that's how they got what they got. Express the decimal value as a percent, which is 8.98%. So Sean's attendance estimate has a percent error of about 9%. He was close, but he was 9% off. All right. The specification of the length of a bolt is 4.75 inches. A machinist makes a bolt that is 4.76 inches long. What is the percent error of the bolt's length? I need to plug my computer in. Running out of juice. Got to plug it in for some reason. And the sun is shining right in my face. Shining right through my window right now. All right. So it's asking us for the percent error. We need to find the difference between the actual value and the value he made. All right. So all we need to do this is 4.769 minus 4.5. And we can add zeros as placeholders, right? So 9 minus 0 is 9, 6 minus 0 is 6, 7 minus 5 is 2. The error is 0.269 inches. So all we need to do is 0.269 divided by 4.75. That will be our percent error. So again, 0.269 divided by 4.75 is this. We will round it off to 3 places. So 0.057. And then to make that into a percent, we go 1, 2, boom, boom, and put our new decimal point there. So we have 5.7%. 5.7% is our percent error for this particular bolt. The bolt is 5.7% too long. All right. Are we making sense? How do we feel? We feel okay. Give me 1 second here, guys. I got a phone call coming in from the teacher. Well, that's weird. There was nobody there. I don't get it. All right. Let's do one more problem just so we're all on the same page. A Park District Flag Football League is changing the number of regular season games for each team from 16 to 18. What is the percent increase for the change in the number of games? So we're going from 16 to 18. So we're adding 2 games, right? And the old total was 16. So all we need to do is 2 divided by 16. The old total was 16, and we're adding 2. So that's the percent change, right? Let's go do this on the Jamboard. 2 additional games, and 16 where it was the previous total. If I put that in a calculator, 2 over 16 equals 0.125. Now I need to make that into a percent. So I need to move the decimal 2 spots over. So my percent is going to be 12.5%. That is your percent change. Easy as that, right? Make a decimal into a percent. We just move it 2 spots to the right and put the decimal in, right? So let's see if we got it right. They're going to show us the bar diagram. This is the old total, 100% was 16. This is the new total. It's the same part plus an additional change, which is 2 games, as they're showing here. The change in the number of games is 2. So they did exactly what we did. 16 games and 2 games is the new total. So 2 divided by 16, 0.125, which is 12.5%, right? We can make a decimal into a percent by multiplying by 100, which is the exact same thing as just moving it 2 spots to the right. I'll demonstrate that. 0.125 times 100 equals 12.5%. All right. I think we have had some positive developments. You guys are getting this. Gabby did great in office hours yesterday. Deasia, are you getting this? Does this make sense to you? Do you have questions? Okay, I got a yes. All right. So we are prepared to do math. We are prepared to do homework. All right, just make sure you keep up on Delta Math. I am going to stop. I'm going to stop the recording, and I will open it up for questions for you guys if you guys want me to help you with anything on your homework. So, okay. Any questions?